Hello, my name is Liz Thompson, and this is IME 315 Financial Decision Making for Engineers at Cal Poly San Luis Obispo. This video is an introduction to the engineering economy portion of the class.
So if we look at the 5 areas that we're covering in this class, this is looking at investment analysis. So today I'm going to talk about the sort of main things like the types of problems that are covered in engineering economy, some of the definitions that are consistent in an engineering economy problem, and the conventions that we use. So the simplest thing in engineering economy is that engineering economy problems need to include time and money. So those are the things. It's not just money. That if you have a question about do you want $200 or do you want $250, this is a pretty easy question because we would just want $250, because it's just about money. There are some problems that are about neither time and money that we need to be thinking about. And for instance, do you want safety or quality? So that doesn't have to do with time and it doesn't have to do with money. Now, sometimes people convert these things to money, but if we're just making decisions about safety or quality or other kinds of non-monetary decisions, we don't use engineering economy. So, like I said, we can sometimes take safety and quality and make them into money. So, for instance, safety saves money because there's less injuries, and you don't have to have as high workers' compensation, and you get better worker satisfaction. Quality also gets you money because you can charge more for your product if it's a higher quality. So there are ways that you can convert these things into money, and then if they have time associated with them, they become engineering economy problems. So when we look at some of the ways that we categorize expenses, money that we're spending, there's two categories that we kind of look into. One is capital expenditures, and this is an accounting term. So this is often something that's an initial expense for a project that will support revenue over several years. And that's kind of the definition, a one-time expense that supports revenue over time. Now, the other area, one of the examples is purchasing an asset, so a machine or a building that will last longer than 1 year. Now, sometimes we buy assets that last just 1 year, like maybe a book. No, that would be something that lasts longer than a year. So maybe some sort of supplies, like office supplies, that's an asset that we purchase, but it only lasts a year. So that's considered an ongoing expense. So these are purchase of items that last less than a year. So any raw material that we use up, that's considered an ongoing expense. Any kind of thing we pay like rent or salary, those are considered ongoing expense. And these are expenses that support revenue in that year only. So the idea that we have one that supports revenue over a time period, that's capital expenditure. The other that supports revenue only for 1 year. Now, some of the ways that we think about engineering economy problems is we use a kind of a timeline. And so if you look at the horizontal line, it has periods, which is 1, 2, 3, 4, 5, 6, 7. Often these are years, but they can also be months or days. They can be different definitions of a period. But most of the time in engineering economy, we think about this as years. The down arrows are ways in which we spend money. The up arrows are ways in which we get money. So for instance, in this example, we have P, which is the dollar that's spent in time period 0. So that means right now. Time period 0 means right now. F is an amount of money that's spent or received at some future time N. So F often means like the end of the project life, but it can also be some other time within that's not time period 0. And A is often thought of as an annual amount that occurs every year for a time for a certain number of years. So if you think about this is like a loan payment. So you make a loan, you get a loan, and then you have to pay it back at an equal amount for multiple periods. This is very common. This A value definition is very common in loan amortization. N is the number of periods, like I say, and I is the interest rate per period. I'm going to talk a little bit about that interest rate per period a little bit later when in another video, when I talk about time value of money. But what this means is how much money would you gain on an amount that's put into an investment, maybe a bank, but how much interest are you expecting to get every year or every period for an investment that you make? And that's what you use in order to do equivalence calculations that, again, we'll talk about in the video, time value of money. Another convention we use is that end of period. So all of the cash flows that occur during the period are assumed to occur at the end of the year or end of the period. So if we have expenses that occur daily, we gather them all up and we put them at the end of the year. And this is what's called an end of year convention. It's used often in engineering economy. So this particular video talked about the conventions and the definition of engineering economy, and this falls under the area of investment analysis.